Hi and welcome. I'm trying to learn Biographyology. Today, Chien, Shiung, Wu, and after we've done it, we're going to do shoulder impingement training. And if you participate in the shoulder impingement training, then it's at your own risk. And this is part 2 of Chien, Shiung, Wu. It was the investigation of a weak force by Chinese-American physicist Chien Shiung Wu that provided one of the most profound demonstrations of the importance of broken symmetries in particle interactions. We're going to come to the part later. One of the most basic symmetries we know of is mirror symmetry. In particle physics, this goes by the name of parity symmetry. Parity. I said it a lot of times wrong. Parity symmetry. A principle that says particle processes, collision and decays, should happen in the same way if all the positions and orientations for particles involve a flip in the mirror. And it's in that way, if there's two times in two different rooms exactly the same atoms and exactly the same way arranged, set up, then all should happen the same way. Every atom should decay in the same way, they should collide in the same way, all the atoms should do it all the same. And now the thing is, in 1956, theorists Sung Dao Lee and Yang Chen showed that parity symmetry was valid for interactions involving electromagnetism and the strong nuclear force, but they found no evidence for it holding in interactions involving the weak nuclear force. So what is the electromagnetism has a force on it, I don't know exactly, is true, and what also the strong nuclear force is doing is true, but the weak nuclear force, it doesn't happen the same way as in the other room, even though everything's the same. Born in China in 1912, Wu moved to the US to do a PhD in 1936. She never saw her parents again. The Second World War and the accession of the communists to power in China meant Wu didn't return to her birth country until 1973, and then only as a tourist. Throwing herself into her work at the University of California, Berkeley, home of a pioneering particle accelerator, she became an authority on beta decay and also worked on the wartime Manhattan Project to build the first nuclear bomb. So what we have here is information. She was born in 1912 in China, and she moved in 1936 to the United States to do research, or we could mention to do her PhD. And I still don't know what PhD means. I encountered it numerous times since we had the first part. I still couldn't find out what PhD means. With 3 letters. And she worked at the University of California. Maybe you're going to say Berkeley. Throwing herself into her work, the University of California, Berkeley, she became an authority. Into her work, throwing herself into her work, the University of California, Berkeley, home of a pioneering particle accelerator, she became an authority. We're going to say University of California if you understand it wrong, if it's wrong. At the University of California, Berkeley. And when we find out that it is wrong, that's basically what I mean. If we never say it, we never find it out. And she researched and studied around it, beta decay. So how neutrons decaying into protons and splitting off an electron. Beta minus decay and beta plus decay. I found better how a proton teams up with an electron and builds a neutron. Beta minus is a neutron into proton splitting with an electron. Beta plus is a proton teaming up with an electron, becoming a neutron. And she built also the Manhattan Project. In 1956, Wu designed and built an experiment at the US National Bureau of Standards in Maryland. So what do we say of it? Maybe everything. US National Bureau of Standards in Maryland. In 1956, this is too much. You're only going to use 5% of our words of our presentation for the name of something. 1956 in Maryland. If you would say it, it is the US National Bureau of Standards. I don't know what's pronounced. I don't even know really what it means. In Maryland. And where she tested it. No, these 2 names. We want to say these 2 names. Sung Dao Lee and Yang Chen. Sung Dao Lee and Yang Chen. Yang Chen. Chien Shiung Wu. Sung Dao Lee and Yang Chen Ning. Yang Chen Ning. Sung Dao Lee and Yang Chen Ning. In 1956, she put cobalt 60 atoms trapped into a magnetic field, and she looked at the reactions in which the emitted beta decay products were decaying, and she found there that actually parity symmetry wasn't there, it was an asymmetry, it was happened differently. This had huge ramifications for experiencing how the weak force worked and provided a first window on other broken symmetries within what became a standard model, including the CP symmetry violation that might explain why matter dominates over antimatter in the universe. I think I'm not speaking clearly enough. So this had huge ramifications for explaining how the weak force worked and provided a first window on other broken symmetries within what became a standard model, including the CP symmetry violation that might explain why matter dominates over antimatter in the universe. And it was actually happened not every time the same. Parity symmetry was broken in particle physics regarding the weak force, and it was the beginning of seeing more asymmetries in the universe. Not only on the weak force work was it important, but also on other asymmetries. First window on other broken symmetries within what became the standard model, including the CP symmetry violation that might explain why matter dominates over antimatter in the universe. And also started the work on other asymmetries. For example, the CP symmetry violation, which is maybe an explanation why antimatter dominates over matter. Why matter dominates over antimatter. This breakthrough led to Li and Yang. So, Zhang Dao Li and Yang Chen-Ning, breakthrough of Zhang Dao Li and Yang Chen-Ning to sharing the Nobel Prize of 1957 for physics, while Chien Shiung Wu got nothing. She went on to do much more seminal work. Okay, she did one more, I don't know what seminal work is, based at Columbia University, and she worked after that at the Columbia University in New York, becoming a fierce critic both of gender discrimination in science and the repressive policies of the Chinese government. She died in New York City in 1997 at the age of 84. Okay, I think we have it all together. Are we able to say that she was born in China, she moved to the US in 1936. And then she became, what is the name for it? She became an authority. She became an important person in beta decay, and she worked also on the Manhattan Project at the end of the Second World War to build the atom bomb. And in 1956, we have Zhang Dao Li and Yang Chen-Ning, and they made some theories about how the strong nuclear force and the electromagnetism are working exactly the same in all the cells the same way. But they had some ideas, but they found no evidence for it holding interactions involving the weak nuclear force. I don't think I speak clearly enough right now. But they found no evidence for it holding in interactions involving the weak nuclear force. But they found no evidence. Do I save it or do I not save it? What are exactly what I mean? But they could not find evidence that it was happening also for a weak nuclear force the same. 1956 in Maryland. She was working at the University of California, and then in Maryland was she doing the experiment. And then at the US National Bureau of Standards in Maryland, she saw cobalt-60 atoms trapped in the electromagnetic field, and then looked in which directions the beta decay was happening. And she found an asymmetry, a parity symmetry, so that everything happened the same way was not happening, and that broke the weak. Parity symmetry was broken by weak interaction, and that showed that the weak interaction does not happen. Parity symmetry does not work regarding the weak interaction in particle physics. And that also was the beginning of understanding more about weak interactions, and also gave an insight on other asymmetries in the universe, and it delivered also a beginning of working on the CP violation, which might be the reason why matter dominates antimatter in the universe. I'm going to say it like that. I'm going to start the same camera. We have a little time left. Chien Shiung. She was born in 1912 in China, and in 1936 she moved to the US. She became an important person in beta decay and also in... I forgot completely what I was saying. What was the other thing? What am I? Chien Shiung. She was born in 1912 in China, and in 1936 she moved to the US. And she became an important important physicist in beta decay, that is neutrons decaying into protons and splitting of an electron, and the other way around, protons sealing up with an electron and getting a neutron. And she worked also on the wartime Manhattan Project, which in 1944-1945 built the atom bomb during the Second World War. Now in 1956, there were Zhang Dao and Yang Chien, and they both made theories about how the strong nuclear force and the electromagnetism work the same in parity symmetry in particle physics. Parity symmetry is the idea that if atoms and everything else is completely the same setup in two different rooms, completely same setup, the same orientation, all the same, the decaying of neutrons and the protons and so on, and also the colliding of the atoms should happen all the same. And they both said in 1956, it happens all the same with a strong nuclear force and the electromagnetism, but we could not find evidence that it happens the same with a weak nuclear force. Now, in the same year, 1956, there was Chien Shiung, and in Maryland, when she set up an experiment, she took cobalt-60 atoms, trapped them inside of electromagnetism, and then looked into which directions the beta decay was happening. And the parity symmetry was broken. It did not happen the same time every time. And that gave much information about how the weak nuclear force happens in the universe, and also insight into other asymmetries in the universe. For example, gave it some footage to work on the CP violation, which maybe is the explanation why there's more matter in the universe than antimatter. And that is according to Richard Webb's Particle Physics Understanding Reality Building Blocks book, page 34. I'm going to stop the camera. Let's pause the biographyology part. If you were here for biographyology, you could go directly to the next part of biographyology. If you stay here and participate in the shoulder pinch training, we're having 2.5 minutes, then it's better honest. We are standing on the bit and short steps. We're going back, and in front, and down. And the other way down, in front, back, and down. A long arm, strong fist, go as far back as you can with shoulders, high up, and front, down, back, up, front, and down, and again up, back, down, front, up, back, and down. And now, world lift, long arm, strong fist, shoulders down, hand together. Turn the arms to the inside. Arms to the outside, shoulders down, together. Arms to the inside, shoulders down, together. Arms to the outside, shoulders down, together. And now the crankshaft of a car which does not know whether forward or back. So the arms to the side, and with the front of the fists, in front of the arms, shoulders down and together. The arms back, shoulders up and in front. Arms in front, shoulders down and together. Arms back, shoulders up and in front. And release. And a shock. Arms up, shoulders up, all down. If this or any other exercise called pain, but not do it. Arms up, shoulders up, and go down. And last time, arms up, shoulders up, and go down. And now stretching one arm in, the elephant trunk. Shoulder back, bend down. Pull the arm in, have flat fingers. Try to relax the arm, go back with the shoulder, turn the palm a bit up to the sky. Pull the arm in, go back with the shoulder, relax the arm. Relax, come back, pull the arm. Pull the arm in, relax, turn the shoulder, turn the palm up. Relax. And the other arm in, shoulder back and down. Pull the arm in, have flat fingers, try to relax the arm. Go back with the shoulder, turn the palm up to the sky. Relax the arm, pull the arm. Pull the arm and go back with the shoulder, relax the arm. Pull in, go back with the shoulder, relax. Relax, go back with the shoulder, pull in. to the power to skydiving legs. And that was Special Olympic training. I thank you very much and until next time.